So turn to page 2, go to the bottom. We're going to start with exercise 2. Do you remember about a week ago we did a ratio table?
Oh, yeah.
Something like this. So we're going to kind of pick up where we left off with that. We're going to be focusing on what's called equivalent ratios today and a couple of ways to show it. All right, exercise 2. Shani and Mel are using ribbon to decorate a project in their art class. The ratio of the length of Shani's ribbon to the length of Mel's ribbon is 7:3. A, let's represent this ratio in a table and show other options. What we do in a ratio table, the very first ratio that we show is called the given ratio. Somewhere in the ratio table, I'd like you to write that. Given ratio. And then maybe an arrow up to the question to show you where that's coming from. If everybody can write that in, that would be great. Yeah, the given ratio is simply the ratio that they give to you in the word problem. What do you remember from Monday? Was it Monday, I think? If I were to ask you to create an equivalent ratio for 7:3, what would be the next ratio in the table that we could write? Angelina.
6 to 14.
6 to 4. You have it reversed. 14 would be first. 14 to 6. How did you do it?
I just added another 3 to the 3 and then another 7 to the 7.
And that was one strategy that I suggested to you. When you see that this is 7 and this is 3, you could very simply count by 7s on the left, count by 3s on the right, and you would be good to go. So if you use that method, what would be the next ratio in the sequence? Olivia. What would this be on? This is 9. Yeah, 21, if you keep adding 7. Okay, does everybody see that relationship of how we're getting those? The other way to look at it, and I'd like you to write this in also, something called rainbows, which I'm going to show to you in the next couple of days. Watch. When we went from 7 to 14, what did we multiply by? Julian. Times 2. That times 2 will also work from 3 to 6. You're multiplying both sides of that ratio by a factor of 2. Ready? This is why I call it rainbows. My next rainbow. To get from 7 to 21, what did you multiply by? 7 times what? Go ahead, Charles. 7 times what makes 21?
3.
Yes. That times 3 will work from 3 to 9 as well. And, well, now watch what I'm going to do. What's my next factor after 3? Multiply by 2, multiply by 3, multiply by 4. Watch what we can do. Starting with 7, bring out the rainbow even further. 7 times 4, everybody.
28.
Can't hear you. 28. 3 times 4, everybody.
12.
And that's our next string in the ratio table. And then you would continue times 5, times 6, and anytime you do that, you're creating equivalent ratios. Or we counted by 7s, we counted by 3s, you could do it that way also. What lesson 3 is going to show you is how we can achieve the same thing using tape diagrams. In the end, ratios and solving ratio problems comes down to you find the best strategy that works for you. My job as a teacher is just to show you all the different strategies and maybe one clicks with you. Okay? So take it to the next page and we're going to kind of illustrate what we just did using a tape diagram. Okay, we can use a tape diagram to represent the ratio of the lengths of ribbon. And just as a reminder, that ratio was 7 to 3. Everybody write that. When we create our tape diagram, the length of Shani's portion of the ratio is going to be how many boxes? John, you got it, 7. Mel's is going to be 3. All right, let's make the tape. Ready? There's my 7 for Shani. Charlie, you good? There's my 3 for Mel. Now I'm going to tell you something that's you're going to hear me say over and over and over and over and over again, and I want you to repeat this after me. Ready? You ready? The tape diagram, repeat, the tape diagram is always the original ratio. One more time. Tape diagram is always the original ratio. That never changes. You'll see what I mean as we build these word problems. So if we have a tape diagram of 7 to 3, it doesn't matter what that word problem says. Our tape diagram is always going to start off with 7 boxes by 3 boxes. Right now, each box represents how many units? Aiden. 1 unit. Write it down. Notice I use the word unit. I haven't given any measurements yet to these boxes. I haven't told you inches. I haven't told you feet. I haven't told you yards, miles. All we know is each box is 1 unit. And our ratio is 7 to 3. Now I'm going to give each box a value. If I told you that each unit is 1 inch, what's the length of Shani's ribbon? What's the length of Mel's ribbon? If each box is 1 inch. Jasmine.
7 inches and 3 inches.
You got it. Write that down. And if each box is 1 inch, then what's our ratio right now, if it's in inches? Andrew, 7 to 3. Ready? Here comes the lead, sort of. Now I'm going to tell you, each box is no longer 1 inch. Each box is now 2 meters. If each box is 2 meters, now what's the length of Shani's and Mel's ribbons? Gabrielle.
14 to 6
14 what?
meters.
Let's give it some length. How many of you agree 14 meters and 6 meters? And you would be right. Here's how it gets illustrated in the tape diagram. Go to the next page. Skip B for right now. And we're going to create the tape diagram. What did I tell you about tape diagrams? The tape diagram is always... What was the original ratio? Make it 7 boxes by 3 boxes. That never changes. Here's what does change. Now I'm giving each box a value of how many meters? Put a little 2 in there. It'll help you to visualize this. Once you see it, you have the option of adding 2 7 times, or it's 2 times how many boxes?
7.
That's where that 14 comes from. 2 plus 2 plus 2, or 2 times 3. And that now becomes the new equivalent ratio, like Gab said, 14 to 6. Now you want to see something neat? Watch this, ready? Look what we did. From here to here, that was our red rainbow. 7 times 2. That times 2, or that 2, is what was put into the tape diagram. That's how tape diagrams relate back to this ratio table. This little multiplication factor is what you put. I call it the magic number. That was the magic number that you put in each box of the tape diagram. That being said, see if you can, on your own, do exercise 4. Now we're going to give the value. Each unit is 3 feet. Make the equivalent ratio, but then you got to prove it using the tape diagram. And I'll walk around the room, and if you get it right, I'll have you come up and do it on the board. All right, so we have our guest student instructor, Angelina. She's going to take you the rest of the way. Go, Angelina.
So first I made 7 boxes. Then I put the number 3 in each. Then since there's 7 boxes and it's 3 feet in each, I did 7 times 3, which is 21. So that gives you the first answer of 21 feet. And then I did 3 boxes with 3 in each. And I did 3 times 3, which will give you your second answer, which is 9 feet.
You got 21 feet and 9 feet. Give yourselves and Angelina a round of applause. Maybe you think Angelina should take over class for the rest of the year. Good job, kiddo.
Thank
And I'm just going to stress to you again as I was walking around, the length of your tape diagram never changes. 7 boxes by 3 boxes will never change. What you put in it will. And again, it relates back to our ratio table. And we just showed, using a tape diagram, the green portion of our rainbow. Okay? All right, we're almost done. I've actually split this lesson into 2 days. I do want to finish up with 5A. Did the number of units in our tape diagrams ever change? Yes or no?
No.
7 by 3. It never changes. Right, the stuff inside does, but the lengths themselves do not. Okay, what are the 3 ratios, 7 to 3, 14 to 6, and 21 to 9? What do they all have in common? And then I have a bonus question for a ticket at the end here. What do these 3 ratios have in common? Well,
They're all multiples of 7 and 3.
okay, that's good. All multiples of 7 and 3. I'll write out the word and. Anything else? Liam? Yeah, they happen to also be something called equivalent ratios. you read this okay? It's a little, these lines are a little tight. And then just to kind of cap this off before I do the bonus question, 7 to 3 was my given ratio. And using the two tape diagrams with a value of 2 and a value of 3, we created two equivalents. You ready for your bonus? Okay. That was good. That was the chuckle of the day. Well, listen, I got a minute, so I got to go to it. Ready? I'm going to give you a question, honestly, that's 2 lessons in the future, just because I'm curious to see if you can do it. Okay? You don't have to write this. I just want you to look on the board, because I have to give you the illustration of what I'm going to ask you here. I'm going to keep the ratio the same. 7 to 3. Shani to Mel. And here comes the question. What if I told you that the length of both of their ribbons together, if you put it together, the length of their ribbons together is 50 feet? What would have to be the length of Shani's ribbon and the length of Mel's ribbon? Again, combined, when they put their ribbons together, it equals 50 feet. What would have to be the length of Shani's ribbon and the length of Mel's ribbon? And again, this comes up in lesson 5. If you can't get it now, you're going to get it by lesson 5. Go, what do you got?
35 feet and 15.
And you would be right. How did you do it?
7 times 5 is 35, and 3 times 5 is 15, and you get 15.
Okay, so which is good. How did you figure out that it's 7 times 5? Where'd that 5 come from? It's like one of those things, I just knew it, right?
Yeah.
See, the idea is, and you're right, if you can figure out what to put in each box, that's how you can do it. All right, anyway, you get a ticket, so stay. And everybody else, have a great lunch.
Everybody